So we're going to continue to do some problems here, more examples of compound inequalities. So the difference in a regular inequality, you just simply have one set of numbers that's true for this. For instance, x is greater than 8. It just means that all the numbers that are bigger than 8 would be true, like 9, 10, and beyond. So all these numbers would make this true if you filled them in or inserted them instead of the x. X is a variable, it can change, and so the numbers that work for that are numbers greater than 8. And for this one, numbers less than or equal to -3, and that's why we have the solid dot in this case. So these are just normal or simple inequalities. But with number 13, it's a compound inequality because we have two things happening basically at the same time, where x is more than, bigger than, -3. So I'm going to put an open circle at -3. And x is also less than 7. So another open circle at 7. And really the numbers between them would make this true. So if x was 0, that's less than 7 and greater than -3. So this is the set of numbers right here that make this true. And so if we go down to number 14, again, a similar situation. We look at the values here. X is really between these two values, between 9 and 4. And really, the 9 is first and the 4 is second. We could flip this around. Really, literally could rewrite this way. 4 is greater than x, and that is 4 is less than x, and x is less than 9. So the way that it's ordered doesn't really change what the x is between. It's between 4 and 9. So the only numbers that are true for this compound inequality are these numbers, the numbers in between 4 and 9. X is greater than 4, x is less than 9. And they're open circles because it doesn't include either of those numbers. In number 15, similar situation. Now we know that x is really between these two, but it includes the number 12. It says 12 is greater than or equal to x. So if I go up to 12, it's going to be a solid dot because of this symbol, greater than or equal to. So it also includes the 12. But x is also greater than -5. So I go down here to -5, and that one's an open circle because again we have just numbers greater than, and then it's everything in between these two. So that's really an and. It's both of these have to be true. It has to be more than -5 and it has to be less than 12. Those are the only set of numbers. Now if we keep going, one more example, we have another OR example. And with the OR, the difference is this or this can be true. So we have a much larger set of numbers. If you see with the and, there's actually a very limited set of answers. Just these numbers here work. With the ORs, there's a whole bunch of answers that work. There's always more with OR because either one of these can be true. So we just start with the first one and graph it. X is greater than 10, which is 10, not including the 10, so open circle, but everything bigger than 10. So 11, 12, 13, etc., all the way on up as far as you want to go. And then x is also, or could be, less than -3. So we go to -3, open circle, it's less than that. And so again, numbers this way forever, really. There's an unlimited number of solutions to the left. There's an unlimited number of solutions to the right. Really, the only numbers that don't work now are these ones in the middle. So x could not be 0. It would not be true if x is less than -3. 0 is not less than -3. It's more than -3. And 0 is not more than 10. So these numbers in here do not work. And so we have two different types of compound inequalities where we have really like an and, this and that. 12 is greater than x and x is greater than -5. Or we have the or situation where one or the other could be true, which again leaves you with a lot more possibilities. Numbers, to infinity to the left and infinity to the right. The only numbers that don't work are these ones in between So it's sort of the opposite if you want to think of it this way. This one and this one are opposites. But those are compound inequalities, and that's the way that you graph them on a number line.